So now we're entering chapter 2, and in this chapter we're going to talk about ways to numerically and graphically organize and display the data. And so don't forget there are two branches of statistics. There's descriptive and then there's inferential. And the descriptive statistics is the methods that we use to collect and organize the data. And then the inferential statistics, that branch covers all the methods that we use to help us draw our conclusions about the data. So the topics that we're going to study in chapter 2 still fall under that category of descriptive statistics. So we're going to talk about 3 types of graphs in this section. There's stem and leaf graphs, which is sometimes called Stemplots. There's line graphs and bar graphs. We're going to start talking about stem and leaf graphs first. And when you have a stem and leaf plot, each number in your data set is going to be separated into a stem and a leaf. The leaf is going to be the last digit in your number, and the stem is going to be everything else to the left of that last digit. So you want to make sure that when you're finished with your graph, that your number of leaves is the same as the number of data values in your data set, because each of those leaves represents a data value in your data set. So that's a way you can make sure that you didn't miss any values in your graph. Okay, so first of all, let me list the steps here. Steps. Okay, step 1 is you want to sort the data because you want to be able to find the smallest and the largest number very quickly, because that's going to help us identify what the stems are. Now, in this data set for this example, it's already sorted for us. We always want to go for this. It's easier to go. I shouldn't say we have to go in increasing order, but it's easier. You want to go in increasing order, so you want to go from smallest to largest. And if you notice, our data set already does that. Now, typically with stem and leaf graphs, the data set's fairly small and it would be easy to do that by hand. If you have a larger set of data though, and you don't want to have to worry about trying to sort the data by hand, there is a way to sort it very quickly on your calculator. Okay, step 2 is you want to identify your stems. Okay, so the stems are going to be the numbers to the left, and your leaf is going to be that last digit on the right. So by identifying the smallest and the largest numbers, we can see what our stems are going to be. So when I look at our data set here in the example, our smallest number is 1.1, and our largest number is 12.3. Since the last digit is going to be our leaves, so in this case, when I look at the smallest number, our leaf for 1.1 is going to be 1, because that's our digit to the right. And for our largest number, our leaf is going to be 3, because that's our digit to the right. And now, so I can identify what my stems are going to be. My stems are going to be the numbers 1 through 12. So in this case, I'm going to have stems. Let me make a note of this. Stems are the numbers 1 through 12 for this example. Okay, now once you identify the stems, you're going to actually, so let me put this as step 3, you're going to draw a vertical line and list your stems. Now it's very important that even if you don't have leaves for that stem, you still need to put that stem in there. And when you list it, you'll just have a blank line there if you have no leaves. Okay, so there's my vertical line, and my stems are going to be the numbers 1 through 12. All right, now the next step, step 4, is to fill in your leaves. Okay, so now this is another reason why it's very handy to have your data values in order, because now I can identify everything that's going to fall under the 1 categories. When I look at 1.1 and 1.5, my leaves for 1 is going to be 1 and 5 because those are my last digits. So I'm going to put 1 and 5. For my stem of 2, I'm going to have 3, 5, and 7. Those are my digits that go with my stems of 2 because these are my digits on the right. Okay, now I'm going to look at 3. So for 3, my leaves are going to be 2, 3, 3, 5, and 8. Now, even though I have a leaf that is listed here twice that's the same, I still need to list that twice in my leaves. So I want to make sure that if there are multiple digits that are the same, I still have that same number of digits in my leaves. So make sure you count those multiples. Another thing that is important here is that you line up your leaves so that they're in columns. So even though we don't write it here, imagine that you have a dotted line separating these so that all your numbers line up. It's important to do that because later when we talk about the shape of the data, if you don't have those lined up, you're not going to get an accurate shape. Okay, so imagine that you have those invisible lines. For stem 4, I'm using these numbers. So I have 0, 2, 5, 5, 7, and 8. For 5, I have 5 and 6. And then for 6, I have the digits for leaves 5 and 7. Now, I don't have any leaves for numbers 7 through 11, so I just leave those blank. And it's important that you do that because if you have, for example, when we have this leaf that goes with 12, you can identify outliers. If I put the 12 right underneath the 6 and I didn't show that gap, it would be hard to see that this was an outlier. So this is kind of off to the side away from the rest of the data. So that's very, very important to make sure that even if you don't have leaves, you still show those stems. The last step, I'll put number 5, is to make your key. Now, the purpose of the key is to make sure whoever's reading the graph will understand what these values represent. So, let's see, I'll write it down over here. So you can pick any number you want. It doesn't matter. I'm going to pick this right here. So I'm going to pick the data value of 3.2. Now, the whole purpose of the key is to make sure that the reader understands what that 3 and that 2 means, because if someone's looking at it, they can interpret that as a 32, for example, even though this really represents 3.2. So in here, I'm going to write 3/2 is equal to 3.2, and then you always want to make sure that you put in your units. The 3.2, that represents, if you look at the problem, that represents kilometers. So I'm going to put in there kilometers. If you forget what units you're dealing with, always go back and look at your question. Now, there are times that you're doing this just to practice, and there won't be any units in the context of a problem. And in that case, you can just write 3/2 is equal to 3.2. But if this is in the context of some problem, you want to make sure that you label what that represents, what the units are. Now, I could have picked, and it honestly doesn't matter, I could have picked 6 and 5 here, and I could have wrote 6-5 is equal to 6.5, and then kilometers. It doesn't matter what number you use. The point is you're just trying to make sure that the reader understands what those numbers represent. Okay, now let's talk about what's called a side-by-side stem and leaf plot. And this is really useful because it allows you to compare two data sets together in one stem plot. And I put on your notes here, you'll see, I think in our book it's called a side-by-side stem plot, but sometimes you might see it listed as a back-to-back, but it's the same thing. Now, going through our steps for a stem plot, it's all going to be the same, except you're going to have two stem plots back to back using one column for the stems. Let's go ahead and put this data in order using our calculators. Okay, let me show you how to sort data in increasing order on your calculator. So the first thing you want to do is you want to enter your data values, and you do that by hitting this stat button right here that's a little bit to the left of your arrows. I'm going to go ahead and hit the stat button. Then what you want to do is you want to access your lists by coming under here where it says edit on number 1. That's where we're going to enter and edit our data values. So then I'm going to hit enter. If you have data already in your list, you can clear the whole list by hitting clear enter, but you have to make sure first that you are highlighted on the list that you want to clear out. So if I want to clear out the entire list 1, I highlight L1 and then I hit clear. Now, if I want to just delete one specific entry, let me just put some data values in there. Let's say I just want to delete the 6 in this case. I would come up to the 6 and make sure that it's highlighted, and then I would use the delete button rather than the clear button. So I would hit delete, and then it would go away. So that's a quick rundown on how you clear or delete entries. Okay, so to enter the data values, we have to do this in two separate lists because we have two data sets. So I'm going to use list 1 for the 3 o'clock class data, and then I'm going to use list 2 for the 8 o'clock data. So to enter your values, you're just going to hit your number and then enter. Okay, and then you're just going to go ahead and enter all those data values just from the 3 o'clock class. So pause this video and just do that. Once you finish your list 1 and you put in all your data values for the 3 o'clock class, then arrow over to the list 2 and go ahead and enter your data values as well. Okay, once you have all your data entered in, one thing you can check to make sure you didn't miss any values is notice when I'm highlighted on this 22 here. If you look at the bottom, we have some notation here. And so what this is telling me is this first number, L2, means my cursor is in list 2, and then 28 means the 28th entry down. So if you want to make sure that you didn't miss any numbers, what you can do is highlight the last number. So the last number that I have on here is 28. So it says I'm sitting in list 2 at entry 30. And if you go back and check, you have 30 data values. So I know I didn't miss any. Now that doesn't mean I didn't make a typo somewhere in between, but at least we know for sure that I didn't miss any. And then you can do the same thing with the first list. If I highlight my last entry, my cursor is sitting in list 1 at entry number 26. And if I count my data values for the first data set, which is for the 3 o'clock class, I can see that I have 26 data values. So I know I didn't miss any. Now, we still want to make sure that we didn't do any typos. So it's probably a good idea for you to always go back and double check, but that will help you determine if you missed anything. Okay, once you get your data values listed in there, we want to sort, for this case, we want to sort the data in increasing order. So what I'm going to do is I'm going to hit the stat button again. Under the edit menu, you'll see an option number 2 that says sort A, and then you'll see an option number 3 that says sort D. These are both sorting functions. The difference between the two is sort A means sort for ascending So that means from lowest to highest, which is what we want. The sort D is descending, so that would be from highest to lowest. So it's just the order in which you want to sort. For us, we want to sort ascend to go in increasing order. So I'm going to hit enter on number 2, and then it will bring us back to our home screen. Now I want to tell it to sort list 1. So I'm going to hit the second button, and then I'm going to hit the number 1 button, because if you see above the 1 button, you'll see list 1. So I want to do the second option first before I hit 1 so that I access that L1. And then I'm going to close parentheses and I'm going to hit enter, and it will say done. Now I'm going to do the same thing for list 2. I'm going to sort list 2. So now I'm going to hit second number 2, so that when I have my sort A and I'm telling it which list to sort, I'm telling it to list the second list now. So that's the L2 above your 2 button. Then I'm going to close parentheses and I'm going to hit enter. And that says done as well. So the calculator just told me that it finished sorting. So now if I hit the stat button and I go back to my edit under option 1, I can go back and see that now my data for list 1 and list 2 is sorted in order from smallest to largest. Oh, and it looks like I have a typo here because we don't have any 2s in this data list. So that is a good indication that I need to go back and check my data. Now that we have the data sorted and you make sure that there are no typos or anything like that in your list, the next step is to identify your stems. Now, because we have 2 data sets, we want to check the low and the high values for both data sets, because the stem in this case, all of those stems need to work for both data sets. So when I look at the lowest value for the 3 p.m. class, it looks like the smallest value is going to be 35. And it looks like the largest value for the 3 o'clock class is going to be 85. Now let's look at the 8 p.m. class. When I look at the 8 p.m. class, it looks like the lowest value is 18, and the highest value for the 8 o'clock class looks like it's 56. Because we want the stem to work for both of these data sets, my lowest value for both of the data sets is 18, and my highest value for both data sets is 85. So I want to make sure that my stems that will work for the numbers 18 to 85. So that means when I write my stems, I'm going to write it so that I have the numbers 1 through 8. 1, because of this 18, that's going to make it so that it works with the lowest number between both data sets. And 8, because that's the maximum between both data sets. And we want all the numbers in between. So I'm going to make my stems here. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now this is going to be in the center because it's going to work for both data sets. So now I need to label which side is which so that it's not confusing. I'm going to put the 3 o'clock class on the left, and I'm going to put the 8 o'clock class on the right. It's important to label everything when you're graphing so there's no confusion. So when we're plotting the data for the 3 o'clock class, it's going to be a little counterintuitive because we want to come from the stem out. Typically when we order numbers, we go left to right. But in this case, because it's coming out to the left, we're going to go order it from right to left. So it's a little counterintuitive, but just keep that in mind. So when you look at the sorted data on your calculator, the first number is 35. So I'm going to list a 5 under 3. Then the next number, if you entered it in right, should be 38. So then I have an 8 coming out this way. So notice what I mean by counterintuitive. Normally we would look at the 5 as being on the left and the 8 as being on the right because we write it in increasing order from left to right. But because the leaves are coming out this way on the left side, you want to make sure that your smaller numbers are closest to the stem. Now I'm going to go ahead and finish writing all my leaves. I would like you guys to try pausing the video and to write your leaves for the 3 o'clock class and then unpause to make sure, and you can check your answer with mine to make sure you got it right. So here are your leaves for the 3 o'clock class. Double check and make sure you got those right. And then we're going to move on to the 8 o'clock class. I'm going to go ahead and do the first couple for you to make sure we've got it right. Now that we're on the right side of the stem and leaf plot, we can actually go and use our intuitive method of going left to right when we're writing our numbers in order. So when you look at your calculator and you look at your sorted list for the 8 o'clock class, you have a bunch of 18s. You should have 5 of them if you entered your data correctly. So that means I'm going to have 5 18s. So I'm going to have 5 8 leaves. And then the next number would be 19. And it looks like you have 5 of those as well. So I'm going to have 5 9s too. So go ahead and pause the video and start making your stem and leaf plot for the 8 o'clock class. And then unpause it and check to make sure it matches with mine. Okay, now this should be your finished product for your back-to-back stem and leaf plot. So now it's an easy way to compare data side to side. And then the last step, we want to make our key so that anybody that's reading this knows exactly what these numbers represent. So I'll use these numbers here. So when you're doing a back-to-back or side-by-side stem plot, you want to make sure that you're including both sides when you make your key. So I want to put down here key, and I'm going to write. Now you can use any number you want on here to identify it. However, I'm going to pick this. So I'm going to do 5/3/1, and I'm going to put that means 35 and 31. And then this is years old. Make sure you include your units in your key. So that is how you make a side-by-side stem plot. You're basically just doing 2 back-to-back where it's sharing the stems. The only thing you have to be careful of is to make sure that when you're doing the left side of the stem plot, that you remember that the numbers closest to the stem should be the lower numbers as you work out. Okay, in the next example, we're going to go over a line graph. And so a line graph is a kind of chart, and it displays the information as a series of data points, and then they're connected by straight line segments. And a lot of times these kinds of graphs are used for showing information over a period of time, but it doesn't have to be that. Okay, so remember when you're drawing a graph that labeling is extremely important. So you want to make sure that you label your axes, and you want to make sure that you scale it properly. And in order to do that, you first need to identify your variables for each axis. So when we look at this first example, it says, in a survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. Our 2 variables are the number of times a teenager is reminded, and then the second variable in this case is the frequency. So what this means is there were 2 students that needed to be reminded no times. If you look at the second data point, there were 5 teenagers that needed to be reminded one time. So that's what this means. I'm going to label the x-axis as the number of times needed for reminding. And then frequency will go on the y-axis. Typically, frequency goes on the y-axis. Okay, so now we have to scale it. If we look at the number of times that teenagers need to be reminded, that's the numbers from 0 to 5. And that's really nice, easy numbers to deal with. So I want to make sure that my x-axis has the numbers on it 0 to 5. So 0 obviously goes here. Because these are not large numbers, I can scale it by 1. If we were using larger numbers, like say numbers that are in the hundreds, I might want to scale it by 20s or by 50s or something else. But you want to make sure that each of those dashes represents the same value. And in this case, each of those dashes represents an increase of 1. Okay, now on the frequency, if you notice, the smallest value is 2 and the highest value is 14. So I want to make sure that it includes all those numbers. If I label it by a scale of 1, then I'm going to have a lot of dashes on that y-axis and it's going to get scrunched in. And I don't like to do that. So I'm going to label it by 2s or 3s or whatever you want to do. I'm going to do 2s, but you can do it however you want. You just have to make sure that each dash is worth the same amount. So I'm going to go by 2s. Okay, then we're going to plot these values. So I'm going to plot the value 0, 2. So let me use a different color for this. Then I'm going to plot the point 1, 5, and then 2, 8, and then 3, 14, and then 4, 7, and then 5, 4. Okay, now with a line graph, you're going to then connect your values of your data values with line segments. So just a straight line like this. Okay, so there's our line graph. Okay, last example, we're going to talk about bar graphs. Okay, bar graph consists of bars that are separated from each other, and each bar is a rectangle, and it can go either horizontal or vertical. It doesn't matter which way you do it. My preference is vertical, so that's how I'm going to do it on here. But if you want to do it horizontal, that's fine. And what we're going to do is we are going to graph the proportions of each of these age groups. So these are our categories, which means each of those categories is going to represent a bar. And then since we're graphing the proportion, this is going to be the height of our bar. Now, if we were graphing the number of Facebook users, then the height of my bar would be based on those numbers. So when I label this, I'm going to put my bars down at the bottom. So I have my first bar is going to represent the age groups from 13 to 25. My next bar is going to represent the age group 26 to 44. And then my next bar is going to represent 45 to 64. So down here, I'm going to label this as age groups. And then along the side here, I'm going to label this as proportion of Facebook users. Now, because we're dealing with percentages here, I would make sure you go up to 100 so that the top is 100%. So I'm going to go, let's say, by 25. You can scale it however you want. I'm going to scale it by 25s. Okay, so now when I draw my bars, the age group that's from 13 to 25 should go up to 45. That's my percentage for the proportion of Facebook users in that age range. So when I make my bar, it's going to come up to 45. So just a little bit before 50. And a lot of times with bar graphs, you'll actually see, you don't have to do this, but a lot of times you'll actually see right above the bar what that height is actually coming up to. For my second bar, it should go up to 36. For my age group between 26 and 44, it goes up to 36. So somewhere in here. And then for my age group from 45 to 64, that goes up to 19%. So it's going to be less than 25. So here's our bar graph. So there's other graphs we can go through, but those are the basic ones that you'll probably see on a regular basis. And these are all ways to organize and display our data, which will come into play later when we are trying to collect information about the data to make decisions. And there are going to be times that some graphs are better to use than the others. There are times where you have to use a specific graph because of the kind of data that you're using. So a lot of information that you have to be familiar with so that you know the best way to summarize and organize your data.